Hi everyone, this is Mr. Horn. This is a quick video about metal properties and alloys. Hopefully at this point you've probably got some good understanding of metal bonding with regards to delocalized electrons and positive metal ions sort of together, and it's the attraction between those two that forms the strong metallic bond. I'm going to talk more today about the properties that arise out of metal structure and bonding, and I'll also talk a little bit about alloys and how you can kind of manipulate the properties of metals based on what you can add to it. So in terms of the objectives for today, the first one is to describe and explain the properties of metals. The second one is to define what an alloy is. And then finally, we're going to contrast and compare the hardness of alloys and pure metals. So first off, let's talk about the properties of these metals. Now, the first one I want to talk about is the melting and boiling points. And for metals, as you can imagine, they're very, very high. Okay, so as at room temperature, metals tend to be solid. Now, the reason why that's the case and why they have high melting and boiling points and therefore a low volatility, it's because of their metallic bonding. Now, in that metallic bonding, as you may have learned before, you've got this attraction between the positive metal ion and the negative delocalized electron. Now, that attraction is very, very strong, okay? Really strong, so much that you need lots of energy to break it. And when you talk about it, you have to say you need lots of energy to break. Let's just write it down here. Now that force is an electrostatic force, which is really strong. And because you need so much energy to break it, it means that metals tend to have melting and boiling points in the thousands of degrees before you turn them into a liquid to kind of loosen the atoms up. Okay, so they tend to have high melting and boiling points for that reason. The second property you need to know about is about their conductivity. And they tend to be very, very good conductors, either when a solid or indeed as a liquid. Now, they're good conductors of electricity. They're also good conductors of heat. The reason for that, again, is because they're delocalized electrons. Now, these delocalized electrons, as you can see from the image below, they can travel through the whole structure. Now, the electrons in this picture are represented by the blue circles, and you can see, or also by the sort of negative signs as well, and you can see that they sort of can travel through the whole thing like so. Okay. Now, because they can travel through, as they make their way through the whole structure, they can carry charge, which means they're conducting electricity, or they can carry energy, which means they're conducting heat. And either way, they can take it throughout the whole structure. Now, when you're talking about this, let's say in an exam question, always mention charge when it's talking about electricity, okay? Really, really important. You can't say, oh, it carries the electricity or carries the current or carries something like that. Otherwise, you're likely to get the question wrong. If you're talking about the conductance of heat, the key word here is energy. It takes or carries the energy through the whole structure. And you know, if you want to use the word thermal energy as opposed to just energy, all the better. The other thing you have to always mention as well is that it carries it through the whole structure. Just saying that it conducts by carrying charge or carrying energy is insufficient. You need to have a little bit more as well. So by saying it takes throughout the whole structure is a really, really good thing to do too. Now, the final property I want to talk about is whether they're hard or whether they're soft. Now, a lot of people get this wrong in an exam because they tend to think that metals are very rigid, strong structures used in skyscrapers and so forth, and they are. But as a pure metals tend to be very, very soft. Now, the reason for that, it's less to do with the bonding and more actually to do with the actual structure. Now, metals are composed of lattices. So you've got the atoms forming rows in a massive 3D arrangement. Now, these rows or these layers are able to slide over each other, and it's relatively easy to do so. So as a result, metals tend to be quite soft. So if you look at the image below here, this is a standard lattice of a metal. You can see that the atoms are arranged in rows, very, very straightforward. On the right-hand side, you can see those layers are able to slide. Now, the key words here, as you can imagine, is layers. You have to mention that metals are forming layers, and secondly, you have to mention that layers can slide. Okay, so that's the third property. Now, metals being soft is actually a huge problem because it means that using a pure metal in a skyscraper or anything like any kind of application can be quite tricky. So as a result, if we want to harden a metal, we can do by just adding other things to it, and that forms something that's called an alloy. Now, at the bottom here, you can see there are two different images. On the left-hand side, this is what I would typically expect to see for a pure metal. So this might be pure iron or pure silver, any pure copper, something like that. On the right-hand side, this is your alloy, and you can see that we've got the atoms from the previous pure metal with a couple of others added to it. Now, as a definition, what you can say is an alloy is a mixture of a metal with another element. Now, that other element can be another metal, such as chromium or vanadium or whatever it may be. It can also be a non-metal, and the most common one that we use is carbon, okay? And if you add carbon, for example, to iron, which is Fe, you make steel, all right? So it's another element. It doesn't have to just be a metal. And the key thing is that it's a mixture and they're not technically bonded together. Now, as an alloy, that gives it lots of interesting new properties. Now, if you look at the top here, that's my pure metal. At the bottom here, that's my alloy. Now, in the pure metal, all the atoms are the same size, okay? So as a result, those layers can slide past each other like we mentioned before. However, in the alloy, you can see that if I add a different element or a different metal to it, it's going to be of a different size because it's different. And as a result, it means that the layers can't slide so well past each other. So the key thing to mention is you've got different size particles, and the word you want to use is that they distort the structure. Okay, any other kind of word that you use is not likely to kind of pick you up marks, so you want to use the word distort. So it distorts the structure, therefore the layers cannot slide past each other. And as a result, alloys can be used for all sorts of purposes. Okay, so you can use alloys to build skyscrapers because it makes them that little bit harder. You can use alloys which have other metals inside it, which makes it resistant to corrosion, such as stainless steel, which contains chromium as a metal, which makes it resistant. So you can kind of manipulate all sorts of properties, but the main one which I'm talking about here is whether it's hard or soft. This makes it a lot harder. So the alloy is really hard now, whereas the iron at the top, which is pure, is much, much softer. Now, when you're writing a long written answer, this is typically what you might get, okay? And this is like a 4 marker, and in this case it says describe and explain the electrical conductivity of metals. Now, the first thing that jumps out at me is the word describe and explain, okay? I just need to mention what it is and then I explain it. And because it's like a 4 marker, the lion's share of the marks is going to be for the explain. I'd expect something like 3 marks for that. Whereas you just need like a mark to describe what it is. And we're talking about conductivity. When you're answering these kind of questions, it's quite good to annotate the paper as much as you can because it shows that you're thinking and you're engaged with what the answer might be. And then the second thing I recommend you do is you brainstorm your keywords. Now, I have kind of 2 techniques for how to do this. One way is by drawing sort of 3 circles. In the first circle, these are my vital words, these are my important words, and these are my useful words, and I kind of write my words in the ring like so before writing my full answer. A lot of students I teach find that quite useful. Or what you might prefer, just kind of put it into a box and write your answer from there. So if I put sort of D here for describe, so this part is going to be for the keywords around that, and E for explain. So if I'm describing the electrical conductivity of metals, well, first off, they're good conductors of heat, right? So I'd say good conductor. I think I said heat a minute ago, I mean electricity, okay? And that's fine. Now, the reasons for that, if you think about what we discussed before, we talked about delocalized electrons carrying charge throughout the whole structure. So my keywords here will be delocalized, electron, and then whole structure, and then also carry, and then charge. Okay, so the first thing you really should do is just get all those keywords down that you think are going to be useful in that answer. And then once you've done that, you can then start constructing your answer sort of 1 sentence at a time. Now, lots of people like to just kind of go straight into it as a long paragraph. Some people prefer to bullet point. It's really up to you how you do it, but I'll show it just sort of 1 point at a time. So the first thing I'm going to say is that it's a good conductor of electricity, and that gives me my first mark, okay? Sometimes I'll give that to you. They'll just say explain why they're good conductor of electricity. Sometimes they keep it a bit more vague like this. And then for the next 3 points, I'll be talking about the explanation why. Okay, so first off, I had to say it has delocalized electrons. Really, really important. I've used one of my keywords. And as I'm using my keywords, another good thing to do is to sort of tick them off. So I've ticked that off because I've used it already. I've used that already, so I can tick that off. The next point is that they carry charge. So I've talked about that word. I've talked about that word. That's been used. I've also used electron. And then they carry through the whole structure. So I've used those words too. So having those keywords sort of planned out early just allows you to make sure your answer is nice and organized. Okay? And that's it. So I hope that's been useful, and best of luck with learning this rather difficult topic.